here we go, 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 here we go.
Welcome back to another episode of Containers on the Couch, the first one for 2024. I don't know where 2023 went, but it was an awesome year, and I'm looking forward even more so to the upcoming year and the amazing guests that we have today. So welcome to the first show. And my name is Meish. I'm going to introduce, let Sushant and Ratnopam introduce themselves. Please, Sushant.
Hey everyone, my name is Sushant Mangalore. I'm a solutions architect here at AWS. Been with AWS for over 3 years now, and I work with customers on ECS and EKS related problems and opportunities. And yeah, looking forward to this. Thanks for having us, Mish.
Awesome.
Hi everyone, Happy New Year to everyone. My name is Ratnopam Chakravarti. I am a container specialist solutions architect. I mainly look after the strategic account segments of the AWS industries, and I help my customers, in their infrastructure modernization journey, and use our container services like ECS and EKS. Happy to be here. Thanks for having us, Maish.
Thank you very much. My pleasure. And my name is Meish Casing. I'm a developer advocate with the ECS service team. Welcome to all our listeners, our regulars like Mike Fiedler, one of our AWS heroes, and also Afan Ahmad, which is also Happy New Year to you as well. Please say hi in the chat. Tell us where you're joining us from. And feel free to ask us anything you would like to do specifically about the topic which you're going to start about, and that is autoscaling on Amazon ECS. So take it away, guys.
Yeah, so this is coming off the back of a talk that Ratnopam and I did at reInvent, which was a chalk talk which could not be recorded. So now we want to bring it to a wider audience. And really, there is a lot of interest in ECS, and especially in scaling. But just to start with a little bit of a background about ECS, right? Like ECS today, so many of our customers are using it for a variety of use cases. There are statistics, right? There are 2.25 billion tasks launched every week. We have about 10,000 API calls being served every second across all of our customers and regions. It's available in all of our regions across 6 continents. So 32 regions, 6 continents, and 65% of customers who start their containers journey on AWS choose to start it with ECS, which talks to the simplicity and the power that ECS offers. And beyond this, many of our own services, AWS services, make use of ECS. So you think about our AI services like Lex or Poly, Transcribe, Translate, all of these make use of ECS behind the scenes. Additionally, even RDS, Redshift, OpenSearch service, these all make use of ECS as well. So thinking about that, right? Like if it's good enough for AWS scale, it is really good enough for a lot of use cases in different industries that our customers operate in.
I mean, if we dog food it ourselves, I assume that we are certain enough that our customers are also going to enjoy using the service as well. So definitely.
For sure, yeah. And our customers, they don't really queue us in before they start using our service. So we observe that they start to use the service, and behind the scenes, we scale it. And our customers don't even really know how much infrastructure or capacity we are provisioning behind the scenes to serve all these requests that they are making. So it's pretty seamless. And that talks to how easily ECS is able to scale behind the scenes for a variety of high traffic workloads and even services such as our own AWS services.
Yeah, and one of the things that ECS does for our customers is that once you have a container orchestration service like ECS, then you can really focus on scaling your application and not having to worry about the underlying infrastructure, because that's what essentially is the responsibility of ECS. And if you are on EC2, then you can ask ECS that, okay, here's a bunch of EC2, and you can go figure out how to deploy and land the tasks on these EC2 instances. And if you are using something like Fargate, which is the Fargate serverless option, then you don't even have to pick your EC2 instances, because that's what Fargate will do for you. So it's what we call the operational heavy lifting, and with ECS, customers can now focus solely on the application specific scaling, nuance.
Yeah. And just to that point, right? Like I always say that the best control plane is the one that you do not have to manage. And that's what ECS
or upgrade,
supports you.
or upgrade
Or
either.
upgrade. Right. And when we do, when we make improvements to control planes, like we increased our task launch rate to 500 tasks a minute for both Fargate and EC2, it's just something that you get automatically. You don't have to think about it. You don't have to do anything additional in terms of your infrastructure. It just becomes available to you immediately. So that's the beauty of ECS.
Yeah.
All right.
There was one question which came into the
from
the chat, which actually I want to start already addressing off the bat, and that was from Afan Ahmad. And the question was, where is it? Here we go. The question was about if we have a pod that has more one container in it, and we need to, why do we need ECS autoscaling as a separate? So I want to just firstly, when we speak about ECS, we don't talk about pods, we talk about tasks. And a task itself is defined by a task definition, which can have multiple different containers inside. And the reason we want to use autoscaling, it's not really separate. It's part of the service which is built in. You don't have to install anything additional. You just have to ask the request to autoscale your service or your cluster in this case, in order for you to do it with capacity providers. And it will automatically expand the number of containers running. We can usually use this for what we call horizontal scaling. In other words, when we know that each unit of our workload of our application handles a certain amount of traffic, and we need to add more and more of these in order to meet the demand in the traffic which is coming in for our service. So that's what we use this autoscaling for, in order to scale our services horizontally. I hope that answered your question.
Right. Yeah, so that's a nice segue actually to talking about the scaling aspects of ECS. So this is a session about scaling. And like you mentioned, Mesh, we want to think about scaling mostly from the point of horizontal scaling, right? Like adding more tasks to serve an increase in traffic. But taking a step back from horizontal scaling, there is some value to doing vertical scaling. Vertical scaling isn't always bad. And in fact, it is something that you should think about doing as an exercise to right size. So Ratnupam, can you talk us through why we would need something like vertical scaling?
Yeah, so the essentially, vertical scaling in theory, it's designed in a way that like you throw more resources or increase the size of your either application, it could be containers, or even the underlying hardware, with the aim to actually serve requests with fewer latency. So it's very simplistic to think that, okay, if let's say I have a 8 vCPU, CPU, and then let's say 8 gigs of RAM, then if you increase that size to, let's say, 32 vCPU and 32 gigs of RAM, the expectation is that your application, and I'm talking about application here, not the underlying hardware, although you can also increase the underlying hardware. But coming back to the application, the expectation is that now, since your application is bigger in size, it can handle requests faster. But the main downside of vertical scaling is that it becomes a single point of failure, because you are only increasing resources for one component. So ideally, in a real world situation, you would like to have horizontal scaling, where you have multiple replicas or shards of your application. But vertical scaling can be a good starting point to establish something what we call as performance envelopes, because that will give you an idea of how much resources in terms of different resource dimensions, be it CPU, GPU, or even memory or network bandwidth that your application is consuming. And
Yep.
once you have that baseline, then you can have a better understanding of your workload, and then design for burst out capabilities. But essentially, the idea of vertical scaling is to have the resources to a point where you have an optimum baseline established.
Mesh, actually, I have a diagram that I want to share. I don't know if that.
Yeah, of course.
Okay.
Here we go.
Yeah, there you go. So Ratnopam,
Yeah.
as
So
you were saying.
exactly. So the idea again is to establish that performance envelope, and there are resources that are compressible, and there are resources which are non-compressible. So again, one of the recommendations that we provide to our customers is that to have this performance baseline, the way to do it is to have continuous load testing. And I want to focus on the continuous part, because having the load test and establishing that performance baseline, doing it right the first time is often not possible. So you'll have to do it continuously as your workload evolves, and this is something we stress a lot on. You can use, there are different tools to do the load testing, but once you use some kind of mechanism to do it continuously, then you will end up with a performance baseline, and then you can start to think right sizing your workload, because right sizing your container workloads is a hard problem to solve, and vertical scaling can give you that starting baseline.
Yep. And to an extent, it goes to also give you an indication of what metric or what dimension your application is bound to. So most applications tend to be CPU bound, but that may not necessarily be the case. So when you do your performance testing or load testing, it brings out the characteristics of your application and really goes to show you that where you're more indexed, and that's the resource that you need to right size on, so that you're getting optimal performance. Because there is no use adding more capacity or scaling horizontally if an individual instance of your task is not going to perform to its best, right? So once you establish that your task is already performing to its best capacity, adding more tasks is going to get you more work done faster.
There was actually one question which I think was interesting from the chat, and it came from not from that one, this one, sorry. Boris Edmonton. Wrong. It's also the wrong one. I apologize. Here we go. So how do you go about deciding the minimum and maximum capacity when it comes to auto scaling? So I think the minimum capacity would be as little as possible as you can actually use.
Mm-hmm.
How would you go about understanding how much you would go for your maximum? Well, how would you do that kind of testing?
Yeah, so you can. So again, like load testing is one of the ways to do it. And so the important thing when you do load test your application is to do it in an environment which mimics your production, because if you cannot simulate the actual production load, and again it depends on how your application is designed. Maybe you have a front end that talks to a back end, and then your back end microservices maybe is talking to a database. So you will have to simulate the exact flow of the request that is happening in production, from all the way from the front end to the actual database layer, and then do the load test with the simulated load, or the expected load at least, right? And once you do that, then as you said, Maish, so the minimum capacity is just about the minimum that you start with. And I would say a good baseline, or a starting baseline, would be to have this vertical auto scaling that gives you this performance envelope, and then slowly you increase the load, and then you try to break the system. And again, depending on your load profile, you can design your load tests in a way that you target certain dimensions, And then once you break it, that then and there, you know that that is your, the threshold at which your application is constrained or is breaking. So that's how you will basically determine the levels of the different dimensions. Does that make
Yep.
sense?
It does, yes, thank you.
Yep. And I was going to add that, like, when you're doing horizontal scaling, and if you want to think about the maximum extent to which you want to scale, at some point you will become constrained by the amount that you're willing to spend to scale, because based on the capacity available, if you don't run into account limits or region limits, you can scale as much as you want. But really, at some point, you have to think about, do I really want to spend so much to scale out, or do I want to offer graceful degradation of performance so that I'm not completely shutting down my website, but maybe my customers see slightly lower performance for a brief duration during the traffic spike? Or you can keep adding capacity, and each time you add more instances, that's going to cost you more. So it's a trade-off at that stage.
Yep.
All right. So
Afan had a question about, is it possible to use vertical and horizontal at the same time? I don't think that is something which we would do, because it kind of messes up the way of how you want to manage your scaling of your application. So how would you address that kind of question?
Yeah, on ECS, there is actually no way to apply vertical scaling automatically, because, again, at the end of the day, vertical scaling is about, having bigger resources. So let's say if you end up deciding to increase the resources for your tasks, then with the scaling policies, you cannot really automatically apply it on the fly. So you'll have to create a new task with those new configuration with, beefy resources, and then you'll have to apply that configuration. So those will be a new deployment of your tasks. But yeah, of course, with horizontal scaling, you can take advantage of the different scaling policies that we have, and then ECS works with other AWS services such as application autoscaling and CloudWatch to automatically trigger the addition or removal of capacity based on the thresholds and the metrics that you choose.
Can I ask you to go back one slide, because there was a question which I think you already have the answer on the slide, and I'll ask it. The question, some Borders Edmonton asked, which load testing tools do you suggest we use? And for example, he gave an environment of how he has a front-end application with replicas connecting to backend and connecting to Postgres database. I see we have on the right-hand side, the load testing. Load testing is key with a couple of options. Can you give us more information about that?
Yeah, you can use tools like, Apache Bench, or even here, or Rackle that we have on the slides. There are other tools that I have seen customers use, like, JMeter for Java-based applications, that is widely used. And there are some like front-end simulating tools also that are out there. That are industry specific or widely used in the industry. So yeah, there is a plethora of options available when it comes to tools.
Yeah, these are some of the open source ones. There are enterprise tools like HP has a load runner, and like Ratnupam said, there is user agent based testing as well, which helps you kind of script your performance testing the way a real user would go about doing things within your application, rather than just bombarding a URL with thousands of requests. Try to simulate a real world scenario of how the user comes in, logs in, then clicks on this button. This action happens behind the scenes. So it gives you a real world feel of how your application is going to be used in production.
Exactly.
All right. So moving on to horizontal scaling from vertical scaling, I guess to answer Afan's question, not together, but vertical scaling or right sizing can be thought of as like a precursor to horizontal scaling. So once you right size, you start to horizontal scale. So Ratnopam, coming back to horizontal scaling.
Yeah. So in horizontal scaling, as I was saying that, so here the key is to choose a metrics or a metric that is reflective of the way that your application behaves. And it is important that you choose a metric that is proportional to the load profile for your application. And we will talk about that later as well, when we talk about what are some of the good versus bad, not so good scaling metrics. But essentially, you want to choose a metrics that can scale proportionally based on your load profile. For example, let's say if you choose average CPU utilization, um, you want that your application is responding to the CPU proportional to the load. So if, for example, you increase the load by 100%, which means that you double the load, the average CPU utilization under normal circumstances, it should also double. Similarly, in the reverse direction, if you reduce it by 50%, then the average utilization should also go down by that percentage. And it is really important that you choose these levels carefully, because the premise of application autoscaling is that you provide the capacity when it is needed. And the other side of this is that, which means basically is that you do not want to have capacity when you don't need it, because capacity at the end of the day comes at a cost. So when autoscaling is done right, you just provide the capacity when it's needed, and that way you optimize the cost and also serve your applications and don't have any disruptions in place.
Let's talk
Yeah.
about the different scaling policies now one by one, because there are a few options here.
Yeah, before doing that, I see there is a question about what is the best way to implement the load testing, right? So one of the ways to do it continuously would be to have some sort of a CI/CD pipeline, and that way it's already built into your life cycle of your product shipment, and you do not do the load testing as a separate exercise. That's just built into the practice. But if that is not the case, then like having it at the end of your development phase would be a good time when you actually want to do that load testing and iterate over it as your development cycle also iterates.
Yeah, I think every major release is usually a good place to load test your application again, because based on the features you have implemented, the characteristics of your application may have changed. You may notice that if you've, say, maybe upgraded to a newer generation EC2 family, you probably do not need as much CPU as you needed in the older generation. So you may be able to bring the reservation of CPU down for that task. So those kind of things you'll discover with every major release that you do.
Exactly. Yeah, so on ECS, and this is about the service scaling. So the fundamental unit of scaling on ECS is a task, and then you group the tasks together as a service. So on ECS, you have three different types of scaling policies that are available. The first one is called the target tracking, and this is a very simplistic way of implementing your scaling policy. This is easy to configure and also easy to maintain, very low maintenance, in fact. All you have to basically do is choose the metric and set the target threshold. And then application auto scaling pretty much does the rest. It works pretty much like a thermostat that you just set the target temperature, and then the thermostat will try to keep the temperature at that level regardless of the external temperature. So here what happens is, based on your chosen metric and the threshold value, the application auto scaling will try to keep the load within that range. And if it goes beyond that on the upside, then it will add more capacity. And then on the opposite direction, if it goes down, it will remove the capacity. One of the on one hand, this target tracking policy or this type of policies is easy to implement and it's very popular with the customers. The downside of the target tracking policy is that it's not very customizable. Of course, you can use custom metrics, and a lot of our customers do that when they want to scale based on different kinds of metrics based on their application. There is a thing called bridge interval in the application autoscaling nomenclature, which basically is a window of time that needs to pass after the threshold is bridged and before the application autoscaler actually can kick in. And this is not configurable. So the idea for this is that you really want the threshold to be bridged consistently, and only after that period has passed, you want to add capacity to your system. Otherwise, if you if the curve just kinds of hang on to that threshold and not breaches it, and you start adding capacity, there is a chance that your system can become too dynamic and can lead to instability. So that's the reason this interval period is there. And this is something that you cannot really control when you're dealing with target tracking policy.
Do we know what that interval is? Is it documented somewhere of how many seconds, minutes, or?
It is typically between 1 and 5 minutes. So, you cannot really go more granular than that. But again, I mean, target tracking works fairly well with most workloads that we see. But again, depending on the workload, it could vary, and you might have to employ different types of policies or combination of policies to cater to that particular demand profile.
Detailed metrics are emitted every minute. Some default metrics are emitted 5 minutes, but like Ratnopam said, it won't breach at the first instance of the metric crossing the threshold. So there is like the number of data points to alarm. So usually that's set to 3 for average CPU utilization. So think of it as 1 minute periods evaluated 3 times. So a minimum of 3 minutes before the alarm is set to alarm state. And from there, autoscaler reacts and starts to scale.
Okay.
Yeah.
All right. So we talked about the limitations of target tracking scaling. So that brings us to step scaling as an alternative to target tracking. So Ratnopam.
Yeah. So with step scaling, the customers have the ability to customize it more than the target tracking, in the sense that they can adjust not only the threshold values at which they want to trigger scaling activities, but also they can do it in a non-linear fashion, meaning that they can set different bounds like lower bounds and upper bounds, and they can also customize the policies to add like, let's say 2 tasks at a time when the threshold is at let's say 70%. So let's say you have a basic threshold, you start with 60, and then you at 70 you want to add, let's say, 20% more capacity. When you reach 75%, you want to increase the rate of scaling. So you can say, okay, at 75%, I want to add, let's say, 4 tasks or 40% more capacity. The thing with step scaling is that you get more options to customize and configuration, but also it is more involved, meaning that you are really like we really encourage our customers to do a proper load testing, identify those threshold values, those bound values, and then also see how their workload reacts to the step adjustments. Like what happens when you add two more tasks, let's say, and what is the effect of adding the increasing rate of tasks to the capacity. Yeah, so this is one option and could work well for your workloads if you really want to react that sensitively to the workload at certain levels. And this is one option, although not very commonly used. This is available on ECS.
Yeah, I mean, it is pretty widely used where customers want to scale faster, like if they do not want to add one task at a time and want to add multiple tasks, this gives the most amount of control. So
Flexibility, yeah.
yeah, flexibility. So with great power comes great responsibility, is how I say it's like. So
Yeah.
you have to be careful. You may end up adding too many tasks when you don't need it. At the same time, you may end up removing too many tasks when you do need the capacity. So that can happen if you misconfigure step scaling. So that's something that, like Ratnopam suggested, load testing will give you a good sense for.
Yeah, and with both, the target tracking and step scaling, it is important to leave certain headrooms for your workload to burst out. Because if you set your thresholds too high, and I have seen instances where it has been set, let's say at 85%, let's say, then depending on which policy you use, you run the risk of bursting and not like having passed the breach interval before your application autoscaling has a chance to actually add capacity. So it's important to again identify that level and leave some headroom for these kind of reasons.
Yep.
Before we go on, I just want to stop for 1 second and welcome everybody that might have joined us either on the recording or have joined us after we started. We are here on Containers from the Couch, first show of 2024. I love the interaction from everybody. Also, yes, also from you, Mike, from all your lovely comments coming in from the chat. And we're talking about autoscaling. We're here with Ratnopam and Sushant, which are both SAs here with AWS. And this is a kind of session which they delivered at reInvent, which was not recorded. So we decided it would be very, very beneficial for all of our customers to get this information out. And here's why we're doing the show. So thank you very much for joining. And back to you, Sushant.
Yeah, so the last option, I think, Ratnopam, did you want to make any other points about the headroom?
Yep.
Because I think there is no exact science there in terms of what's a good percentage, right? Like we've seen 70% as a threshold work pretty well for average CPU utilization, but different metrics could have different thresholds. So
exactly,
and it will depend specifically on the application and what the use case is for the specific customer. So definitely try this out yourself and get to the right numbers on your own.
Mm-hmm.
Yep. And then moving on, we have a third kind of scaling that is available on ECS, which is schedule scaling. And as the name suggests, you can have scaling at a predefined interval. Let's say you have designed an app and you anticipate that on certain days that app might be used heavily. So you work with your team, your operations team, to provide or provision that capacity beforehand, so that when that demand hits, you already have the scaling available. So that's again, it's fairly straightforward and works well with this kind of anticipated demands.
Yep.
Some of the things which I've seen customers in the field, for example, using is that they have a service which they know that everybody's going to hit at 6 o'clock in the evening when everybody goes home, and start bombarding it. And they know that everybody goes to sleep at 12 o'clock at night, so they can scale it down again until the morning and bring it down to practically whatever they need. And they save a lot of money in that way. And it's automatic. It's set on a timer in this case, pretty much, and they don't have to touch it.
Yes. Yep. Yep.
And what's also interesting is that you can combine and mix and match some of these scaling policies. So when you have multiple of these, for example, if you have scheduled scaling and target tracking on your service at the same time, ECS tries to prioritize higher availability. So whichever scaling policy results in more tasks or more capacity, that one will be prioritized over the one that's so you can have both in place, and at different points, it will help you in different ways.
Exactly. Yep.
Yep. So on ECS, apart from the service level scaling policies, you can basically increase the amount of tasks or reduce them based on the thresholds or the metrics you choose. But what if your underlying capacity, is exhausted? So in those cases, also ECS covers you with something called cluster capacity scaling in the form of capacity providers. Sushant, do you want to talk about that?
Yeah, so a nice analogy here is that maybe you are at a bus stop and you're trying to get into the bus and the bus is full. So you want to wait for the next one, right? So that's how capacity provider works in a way where if the existing set of container instances is not able to accommodate more tasks or schedule more tasks, an auto scaling mechanism, which works on EC2 instances in this case, it's still application auto scaling, but the scalable target in this case is EC2, and it will create more instances and allow those tasks to be scheduled on those. Of course, if you're using Fargate capacity provider, then you're not waiting for a bus. It's like getting your own Uber, so it brings its own capacity with it, right? So that's different.
I love that.
But yeah, so in that case, you just get more capacity that's available. But there is still the idea of capacity providers when it comes to Fargate. But I'll talk about that in a bit. But the idea behind capacity providers really giving you more capacity when you need it, just in time, and it works based on the whole idea of auto scaling. So when there is no resources available in the existing set of instances to schedule more tasks, auto scaling kicks in, creates more instances, scales your cluster up, not your service anymore, cluster up, brings more capacity, allows those tasks to be scheduled. Now, I just mentioned that with Fargate, you don't have to worry about capacity, but there is still the idea of capacity provider when it comes to Fargate. And why that is there is this additional Fargate capacity called Fargate Spot. And the only way to access that is through the use of capacity providers. So what Fargate Spot affords you is Fargate capacity, and it's many times up to 70% cheaper than the Fargate on-demand capacity. So to access that, the only way to do that is to use Fargate capacity providers. And both Fargate and Fargate Spot capacity providers are automatically available to you when you create a new service in ECS. And if you're using the Fargate launch type, it starts to make use of those capacities. Fargate Spot, if you want to use, you need to specify how much base and weight you want to assign to your capacity providers. So let me talk about that a little bit. So base determines how many of your tasks should initially use the capacity provider that has a non-zero base. So imagine you have two capacity providers, one for Fargate and one for Fargate Spot. You can say something like, I want my first 10 tasks to always use the Fargate capacity provider. And then when I have to scale beyond that, then it can make use of Fargate Spot because I'm assured that I'll get my 10 tasks capacity from the Fargate capacity pool, because Fargate Spot capacity is not always guaranteed. So you want to use that in situations where you're scaling beyond your base capacity requirements. So with that, you're getting the best of both worlds. You're getting capacity from Fargate, managed capacity that you do not have to worry about patching or anything. And then when you have to scale and you want to do it at a cheaper cost, you use Fargate Spot capacity provider.
Yeah, and Sushant, like customers can also use the service scaling in combination with using capacity providers, right? So that
Yep.
they have coverage from both the service perspective as well as from the underlying capacity perspective, right?
Yeah, so always try to scale out by tasks as much as you can. But when you run into capacity limits on your EC2 instances, your capacity provider kicks in and scales out your cluster, allows additional tasks to be scheduled on more capacity that's requested. So one thing that is also a thing that you need to keep in mind with capacity providers is the target capacity percentage. So 100% capacity, target capacity ensures that all of your EC2 instances are utilized for scheduling tasks. But if you want to keep some additional capacity, which is unused, which allows you to scale faster, you can set your target capacity to 90%. So 10% of capacity is kept unutilized. But what it does is allows you to have some pre-initialized EC2 instances, which can allow you to scale faster when you need to.
And if we go back to your bus analogy, it kind of queues up the buses in the background that people can pile onto it instead of having to wait for in the rain for a new bus to come on the road.
Exactly. Yeah. A bus is already there waiting for you.
Exactly. Mm-hmm. There is one thing I want to just point out that you did mention, and I want to just make it very clear. The fact of the capacity provider, using capacity provider with Fargate and Fargate Spot. When you do your weights, for example, you mentioned the thing of 10 weight of 10 for Fargate and 2 for Fargate Spot. Fargate Spot is I wouldn't say a luxury, but it is a capability which we provide if we have it inside the data center in that specific time.
Exactly.
That means it's not guaranteed. That means you will not necessarily, when you say, I want a Fargate Spot container or some to launch a new task on Fargate Spot, you will get that task. It depends on a number of parameters on the background of pricing, of mostly of available capacity in the data center or in the availability zone or in the region. Mm-hmm. If that capacity is not available, your service will not scale until it actually gets that capacity. So when you do, make sure that you have already fulfilled your required scaling metric. In other words, for example, you needed 10. And if you wanted to add that extra oomph that you wanted to give to your service to add that extra 2, which would give an extra, but it's not 100% necessary, and my service will not fail if I don't get those extra 2, then you can say, okay, I'll go for those Spot because it'll be cheaper, and it's a nice to have, but it's not something which you can rely 100% on your production workloads. At Fargate Spot, will be able to provide you all the capacity that you request.
Right. And the other thing to keep in mind with Fargate Spot is that they can be interrupted at any point in time. So
exactly. We will yank it back when we need it. Exactly.
Yeah. So you get the 2-minute warning, and you need to be prepared for your application to complete any work that's pending within those 2 minutes and gracefully exit. So that way, the Fargate Spot capacity can go away at any point in time. So use it when you have to scale at a cheaper price, but don't always rely on it being available for you. All right, so now let's get to some of the metrics that we talked about in terms of what is a good metric for scaling your applications on. And again, this is talking more about horizontal scaling here. Assuming you've done your vertical scaling and you arrived at the right-sized instances, you want to add more tasks as your load increases. So this is some of the real-world examples that we've seen work well and not so well. So average CPU utilization is almost always a good indicator of a well-designed application, that your application is CPU bound and you're able to scale based on your CPU. So as the load increases, as your load increases, the CPU utilization also increases. And from there, you're able to add more capacity or more tasks and scale out your cluster. Sorry, I'm losing my voice here.
Yeah. And the same way, the average queue depth is also a very good scaling metrics because let's say there's a supermarket analogy that we refer. So you have gone to a supermarket and there's a queue at the counter. So if you add more counters, then the processing time becomes faster. So average queue depth, like scaling on the basis of average queue depth and the length of the queue is almost always a good scaling metrics. Of course, it depends on the asynchronous nature of your applications, but it is a good metrics to scale on. What are not so good metrics to scale on? So one is right up there, that is not recommended to scale on, is memory utilization. Why? Because with most of the application programming languages that are used today, they tend to gather memory as as they get initialized and starts to serve traffic. Now, what doesn't happen is the applications don't release memory as fast, even if the load profile goes down. So yes, there are things like garbage collections that frees up the memory from time to time, but those things depend a lot on how your application code is written, and if you are in your code you're not leaking memory and you're freeing up, or you're allowing to for the garbage collector to come and release those memory back to the kernel. But in general, with the load, even if the load decreases, the memory is not released as fast. And so if you base your scaling metric based on your memory utilization, you will end up adding more tasks, but still the memory utilization might not go down that much.
Yep.
um,
And
yep.
what's also an indicator, if you're seeing that your application is memory bound, there is also a chance that there is an opportunity to optimize your application a little bit. Maybe there is a memory leak, and maybe you're acquiring too much memory without really using it, or having it fall out of scope so that it can be garbage collected. So there may be opportunities to better utilize your memory. And yeah, so from that point of view, when was the last time? I mean, I know in the there are languages like C++ where you can acquire and release memory, but we haven't written code like that in a long time. So we do need to rely on garbage collection to happen, and you need to facilitate that with good code that you write. All right, so talking about some of the other options here for not so good metrics for scaling, right? We try to avoid using average response time because we look at it as a second order metric. Usually, the average response time uh, could be something that is not related to your application tier at all, right? Your application may be dependent on a database, which may be deadlocked or may be facing more load than it can handle. And at that stage, scaling your application tier is not going to solve the problem. So you're relying on a second order metric, which is the response time. Instead, a better way to solve the problem is to determine the true root cause of why your response times are slowing down, or rather response times are increasing. And in that case, find the actual root cause why, which is causing the response times to slow down, and use that as the scaling metric. And if it is CPU, then yes, scale by CPU, and you are going to get the benefit of application tiering or application auto-scaling. But if it is something else, if it's like a third-party API that your application is calling, or a database, in that case, try to address that problem first before you think about scaling your application tier. Yep.
Yeah, one of the other things with average response time, and also a similar metric would be the request rate, right? So with this kind of metrics, if you scale based on this, you are assuming that your requests are behaving uniformly, while in the field or your at production, you might have requests that are fairly large. Let's say you have a large payload in your request, and your service has to unpack that payload and then process based on the application logic that you have. And for a huge payload, it might have a big response time. But again, for a smaller payload which is not doing much, you would end up with lesser amount of response time. So you if you do the average and you have more smaller number of requests, then you really scale based on something which is not uniform. So that is why we don't encourage to scale based on the second order metrics.
Yep. And there's a subtle difference between something like an average queue depth and the number of requests. With average queue depth, we usually assume that all the requests that are arriving on the queue are going to take the same amount of resources or same amount of time to process. So that is still a safe one to scale by. Whereas just purely request rate, like Ratnupam said, different requests could have different needs. Some requests could take longer, some requests could take less time. So the average may look good, but you may find that some of your workers are running more hot than others. So for that reason, average queue depth usually has the same kind of requests uniformly. So that becomes an easier metric to scale by. I noticed a question here about p-values. So I was just going to come to that. So both max and p-values usually are indicators of some kind of an outlier in terms of your metric usage. And what the problem this can cause is not a lack of capacity, but a problem of runaway scaling. You may end up adding more capacity than you need because you see that this outlier metric, which may occur once every while, but it's not sustained. So sustained p-values, that may be questionable, but if it is something that is like an outlier metric, definitely do not scale by that. Average in that case becomes a much more safer metric to scale by.
For those who are not maybe what are p-values, if you can just give us a quick thing about what that means, like p99, p95, what does that mean?
So p95, for example, means that these set of requests are slower than this set of metrics is better than 95% or more than 95% of your total set of requests, right? So in this case, the 5% that is not complying with the average, it is what the p-value suggests.
Yeah, it's a percentile.
It's a percentile, yes.
Percentile. Okay, perfect.
All right, so those are some of the metrics that we recommend and we do not recommend. I guess in the last 2 or 3 minutes that we have here, we can just talk about some of the things to keep in mind when you're scaling. Definitely plan for different quota limits, right? Make sure that you have enough IP addresses in your subnet. You have thought about how many targets you can attach to your load balancer. Because even if everything else is configured well, you can run into these kind of challenges when it's time to scale, right?
Yeah, especially with the the IP addresses on IPv4.
Mm-hmm.
I have seen customers run into these issues of IP exhaustion quite a lot, and so what we suggest in that case is exactly what Sushant suggested. Like, start with a big enough CIDR range, keeping your application growth and scaling in mind. If you can, start with a /16 CIDR to have a lot of IP addresses available. But if it is not possible, then at least start with the next bigger range that is possible. And if you cannot use any more, then use something like a secondary CIDR, and then your tasks can have IPs from the secondary CIDR range, and then place. But those would be from what we call the 164 range, which is kind of non-routable. So you will have to place your tasks on a routable. Either the best way to do it is place the tasks to attach to a load balancer, which sits on a public subnet and is routable, and then place the backend tasks on those non-routable CIDRs. But at least you will not have the issue of IP exhaustion in this way. Yeah.
Yeah. The other recommendation is always, needless to say, keep your base images small. Use techniques like multi-stage builds. There's Sochi. So the faster your container can start up, the faster your scaling is also going to be. Because anytime your scaling is slow, usually it's a byproduct of the fact that your image pool sizes are too large, and then you have to unpack the image, start the application. That tends to add a lot of time. And then your application has to register with the load balancer, all the health checks have to pass. So you may need to fine tune some of those uh, metrics as well to ensure that your application starts responding in time. And if you know that your application can get healthy faster than our default values for those metrics, then you can fine tune those as well. Right.
Awesome. That was a lot of information and a lot of amazing information. And I'm really, 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 really glad that we actually got this on camera, because, as I said, it was nice to have the however many 50, 100 people you had in the room at reInvent to get this information. But it wasn't recorded. And now it is out there recorded, that people can also use this as well. Before we go, I want to see, is the question from Mike of how you can find the timing of image pools to see if size is a bottleneck, everything there. You can use that with the CloudTrail, which will give you all the information of when the image was pulled and when it was started. All that information is available in CloudTrail as well. So you should be able to get that information from your logs.
I think there's an ECS task metadata endpoint as well, which
also exactly you can also query that as well.
Yes.
Right. Any closing remarks from either of you gentlemen that you would like to share with us before we close out for today?
No, I mean, thank you for having us today. This is definitely an exciting topic. I think, as hard as it is, the powerful nature of the scalability that ECS offers sometimes tends to be underestimated in comparison with something like Kubernetes. But as you saw today, there is a lot ECS can do, and I really like to see more of our users start to use ECS for their container workloads.
Yeah, ECS stands out, for its simplicity, and with the scaling capabilities that we just talked about, and we barely touched some of the aspects. There are aspects that we can go at depth of each of the topics that we discussed. But with all these capabilities available on ECS, if you do your auto scaling right, meaning that you profile your apps, you load test, you find out the baselines, and then you continuously iterate over it and improve, and most importantly, choose the right kind of metrics to scale on. I think that's very important. That I want to really drive the point. Then you should see good performance. But at the end of the day, it depends on your nature of the workload and the application. You might have to use a combination of different policies and mechanisms that we talked about. And if you need help, please reach out to us.
Awesome. So thank you both. Thank you, Ratnopam, and thank you, Sushant, for an awesome session. My name is Mesh. My Twitter handle here is on the screen. If you have any questions, the DMs are open, so please feel free to reach out. If you have any questions for either Ratnopam or Sushant, you can forward them to me and I'll pass it on as well, because we don't have their socials here on the screen, but that's okay. Thank you for joining. Thank you for participating, all the people in the chat. It was awesome to have your feedback and your interaction. And we will see you next week, not with an ECS session, but with an ECS session. Next week, same time, same place, Containers on the Couch. Don't forget to hit the subscribe button on the Twitch channel. Also the subscribe and notifications for the YouTube channel. Love having you here. And this was an awesome kickoff for 2024. Thank you very much, everybody.
Thank you.
Thank you.